Okay, let's see here. Let me share my, so we have a few people in here. It looks like my microphone is working. I got the record on. All right. Looks like there's a chat here for Zoom. Everyone will have to bear with me. This is the first time I've used Zoom before, so I'm just kind of getting the hang of it. Please, somebody let me know if you cannot hear me, but you should be able to hear me. Looks like I'm sharing this screen. Make sure I'm sharing the correct one. Where's stop share? Let's do screen share and do the screen, share it. Okay. Let me make sure I have my little chat up here in case somebody has a question somewhere, and then we'll get started. Participants, there we go. Yeah. So you can feel free to, I guess, get on the audio and ask a question if you want to. If not, you can type it in. There's like a little chat thing for Zoom. You kind of just have to find it for some of you Zoom. Basically, what I'm going to do is I'm going to go over project one. I'll kind of code it up from scratch, so you can kind of see what I'm looking for, where you may have went wrong, and things like that. So you should be able to see my screen. I like using IntelliJ IDEA as my IDE. I mean, you can use Notepad if you want, whatever the case is. I like using IntelliJ. It's a nice IDE for programming in Java. But I've already got the project set up. I just created a new project for this project one weights. I already have the project one class and the weight files created. And what I'm going to do is basically just go down the PDF file and read off each of the steps along the way, and we'll program it up. So the first thing it says for programming project one is the first class is a weight class. So I'll go to my weight file. I have a weight class, public class weight. It says it has an integer pounds. So let's make an integer pounds. It says and ounces stored as double precision. So we'll have a double ounces. Easy as that. It should have the following 5 public methods. A public constructor. So a public, the constructor has the same name as the class. And that allows the pounds and ounces to be initialized to the values supplied as parameters. So we need to give it parameters for pounds and ounces. We'll come back in and do the actual work in the classes once we get each of the methods made out. A public instance method, a public instance method named less than. It's Boolean, I'll show why in a second. Less than, that accepts one weight as a parameter. So I have weight as a parameter. And it returns whether the weight object is less than the weight supplied. But we'll come back and fill that in. A public instance method named add2 that accepts one weight as a parameter. All right. A public instance method named divide, public void divide, that accepts an integer divisor as a parameter, int divisor. A public instance toString method, public toString method that returns a string. A private instance method, so now we're going to private instance method, 2 ounces that returns the number of ounces in the weight. So return the double 2 ounces. And a private instance method normalize, private void normalize. And it says what it should do. Okay. And that's all the things that should be in the class. So let's go back and fill out what should actually happen. So with the constructor, we're passing in a pounds and an ounces And we have our own internal class variables here, pounds and ounces, that should be set to these. We're giving this weight class the pounds and ounces, and we want the weight class to store those. I like using this anytime I reference the internal variables of a class. I like using the this keyword because it helps differentiate between the class variables and what you pass in as parameters. So I have this dot pounds. I'm specifically talking about the class pounds. And I can have it equal to just the normal pounds, which is what's passed in as a parameter. The same thing with ounces. And my constructor's done now. Well, one thing we can do on here is, and we should do, we'll come back to it. It has to do with the normalized method. All right. So now let's look at what less than should do. So it says less than, it returns whether the weight object on which it is invoked is less than the weight supplied as a parameter. So we need to find out if this weight is less than this weight parameter. Well, we can do it. First, we can do it as just comparing the pounds. So we say if this pounds is less than the weight pounds, so if this is pounds is less than that's pounds, then true, it is less than. What if this pounds is greater than weight dot pounds, then it is not less than, right? But now we have another case. What if the pounds are equal? So if this has less pounds, it does this. If it has more pounds, it does this. So if the pounds are the same, we're going to get right here, and then you have to compare the ounces. So if this if I spell ounces, if this ounces is less than the weight dot ounces, then it's less than. Now, if all of these things fail, then that means the pounds are equal, because this will catch if the pounds are not equal. This is if the pounds are equal, but this has less ounces. So this is the only remaining case where the pounds are equal, but the weight has less ounces. And so it returns false, that's not less than. Easy enough. All right, now we have the add to method. What the add to says, the add to method adds the weight supplied as a parameter to the weight object on which it is invoked. It should normalize the result. So we need to add the pounds together, add the ounces together, and normalize. So this dot pounds plus equals weight dot pounds. And what the plus equal just means, it means this dot pounds equals this dot pounds plus weight dot pounds. It's just a little more concise. All right. We also need to add the ounces together. This ounces plus equals the weight dot ounces. But then we need to normalize. And we'll see later when we get to the normalized function, what that does is just, it makes sure the ounces is not greater than 16. Because once ounces is greater than 16, it means it's a pound. For example, you don't have 22 ounces. You have 1 pound and, what was that, like 6 ounces, right? And so that's what the normalized function will do. So all we have to do is just call normalize, and it'll take care of that for us. That's all there is to add to. Now we go to divide. And it says it should divide the weight object on which the method is invoked by the supplied divisor and normalize the result. Well, let's just go ahead and put normalize here. And that'll go at the end because that's the last thing we'll do. Now here's where you can get tricky. So you may think that you can do this dot pounds divided by equals divisor, right? And this dot ounces divided by equals divisor, right? You think that may work, it actually doesn't. And the problem is with the pounds right here. Why? Because if we look, pounds is an integer, right? So we're saying integer pounds divided by integer divisor. So what happens when you're dividing ints in Java? The same thing applies to C and C++ and most programming languages. Is when you divide integers, the result is an integer. So for example, if pounds was equal to 3, then pounds divided by 2 equals what? Does that equal 1.5 like it should? No, it doesn't. Pounds divided by 2 will equal 1. That's because 3 divided by 2 is really 1.5, but when you're doing integer division, when the numerator and denominator are both integers, then you only get an integer result. And so if we do this just right here, unless these are evenly divisible by each other, we're throwing away that fractional part, which 0.5 pounds is really 8 ounces, so we're losing 8 ounces in our answer. So we can't do it like that. A good way to do it is utilizing our 2 ounces method. And let's fill that one out real fast, and you'll see why we can use it. So let's look at our 2 ounces. It returns the total number of ounces in the weight object on which it was invoked. Okay, so we need to take this weight, the pounds and the ounces, and return it as a number representing total ounces. Well, we can return, so we'll have this dot pounds, multiply it by 16 because there are 16 ounces in a pound, and then add this dot ounces. What this will do, it'll take our weight that's represented in pounds and ounces, it converts it to just ounces and returns it. So you can think of our 2 ounces method as how much it weighs in ounces only. Okay, so let's look up here at the divide. So let's get double total ounces will equal this dot 2 ounces. So now we have a number here. Total ounces is how much it weighs in ounces only. We're not worrying about pounds anymore. Okay, let's clear out our pounds, and now let's make our ounces equal to this. So what did I just do? So now in our weight object here, the pounds is equal to 0, and the ounces is equal to the total number of ounces that are in there, right? And luckily, this dot ounces is a double, or total ounces is a double also. So what we can do, we can now divide this by the divisor. Now the divisor is still an integer, but the total ounces is a double, so it'll remain the fractional part. So even if we had, say, 5 ounces, we'll have 5 ounces divided by 2, it'll still give us the 2.5. We'll still retain that fractional part. Now what can happen here, and then of course we normalize it, because what if this dot ounces ended up being 50 or something, right? We need to renormalize it to convert back to those pounds and ounces in a normal representation. So that's all there is to the divide. Since we'll go back one more step up here, but since we have this 2 ounces, it's the, like I said, it's the total weight of the object in ounces. We can come back up here and we can actually simplify this. And how can we do that? Well, let's get, if this ounce, total ounces, is less than the weight's 2 ounces, then we can just return true. Else, return false. We don't need the rest of that. The reason why is because once it's in this 2 ounces, it's just ounces. It doesn't have anything to do with pounds anymore. So we can compare the ounces directly. So let's simplify that up a little bit. All right, let's close those. Done with those. ToString, real simple. We just need to print. We just need to put a string in a format that looks nice to look at. And there's a lot of ways to do this. I'm just going to do it really simple. We're going to return. We're going to make a string. And Java's really good about this. We're going to return the ounces plus. And once we start doing strings, it'll convert this pounds to a string for us. So let's have this pounds, LBS, plus ounces, and OZS, I guess. That's all there is to it. So when the string returns, even though this is an integer and this is a double, because we're adding them to strings, Java is smart enough to figure out that we want this whole thing converted to a string. So that's all there is to the toString. All right, we already talked about the 2 ounces. All right, here we have the normalize. And normalize method says, it normalizes the weight on which it is invoked by ensuring that the number of ounces is less than the number of ounces in a pound, right? So if our ounces was, say, 17, right, then really this should say we have 1 pound, 1 ounce instead of 17 ounces, right? Easiest way to do this is with a while loop. So while ounces is greater than 16, actually greater than or equal to, because if it's also equal to 16, we want to add a pound and reset the ounces, okay? So this means this dot ounces is 16 or greater. If that's the case, then we want to increase pounds by 1, because we're adding a pound, but this dot ounces and reduce the ounces by 16. Now, the reason we don't just set ounces all the way down to 0 is because, for example, what if this dot ounces was 33, okay? So the first time it comes in here, ounces is 33. It is greater than or equal to 16. Sorry, somebody just messaged me something else. I'll get back to it. So this dot ounces is 33. It is greater than 16. So we're going to add 1 to the pound, and we're going to subtract 16 ounces. So now ounces is, was it 17? Come back up here. This is also the case. And so we add another pound and we subtract away the ounces again. So that's all there is to the normalized method. Oh, I missed spelling. All right, now it's normalized. And of course I got to fix the spellings up here now. And that is all to our weight class. That's simple. That's sweet. All right, bear with me 1 second. It looks like a okay. All right, I hope you guys can hear me. I sincerely apologize. Like I said, this is the first time I've used Zoom, and I knew there were going to be some hiccups. I didn't know I had to click the accept button to accept you into the room. I just assumed you were. But I hope you can all hear me now. I have already typed up this weight class without any of you seeing it, actually. And I guess I will go through and explain it quickly, but this video is being recorded as well. Actually, I'm not going to go through and explain it right now. I will make sure the recorded video gets out so everyone can watch it to see how the weight class was constructed. So just we'll go back to the video for that. As I said, if you need to ask a question or anything, unmute your mic and ask the question, or type it into the chat box. Can somebody at least give me an audio that they can hear me and they can see my screen share, or at least put it in the chat box that they can see it? All right, so it looks like I got somebody to say that they can hear and see it, so we're good. As I said, I already did up the weight class, but I'll release the recorded video so that you can see it. One thing about the Zoom, I guess the free one limits me to 40-minute meetings. If we start to run out of time, I have another one set up, and I'll just need you all to join that. First time Zoom user, so I'm getting used to it. All right, so that's the weight class. Go back and see the recorded video for how I constructed all of it. All right, so now we'll look at the project 1 class. And as I said, we're just going to read down the PDF and we'll implement each thing as it shows up on the PDF. All right. So it says we should have a project named Project 1. We have a Project 1. It should consist of the following 4 static methods. It should have a main method, which we have here. It should have another method named find minimum, a private static find minimum that takes an array of weights and the number of them. it says we should have another method called find maximum. Maximum. And the PDF says we should have another method called find average. And it says each one of these methods will be static, private. It says it in the PDF. It'll return a weight, which is what is here. And it'll take an array of weights and a count of the number of weights. Okay? And those are the only 4 methods that we need in our Project 1 class. So let's read what each of the classes should do. Let's start with these 3 down here because they're a lot simpler, and then we'll get to the main method. So it says the find minimum is it accepts an array of weights as a parameter together with the number of weights. It should return the smallest weight in the array. So how do we find the smallest weight? Well, first we'll have a variable to track what the smallest is. And what should it be? We'll just have it be the first weight in there. So far the smallest is the first weight in the array. Now we need a loop for int I equals 0. We can start at 0, but we've already looked at weight 0 here. So really we can start at weight 1. How many of them do we go through? The number of them. And we'll increment I. So now we need to see if the weight at this index is smaller, and if it is the new smallest. So if the weights of I is less than the method in our weight class, the smallest. So this is saying if the weights at this index is less than the smallest one so far, then it now becomes the smallest. And after that loop runs through the number of weights, we're done. Easy peasy. All right. Find maximum, almost identical, except instead of finding the smallest, we're finding the largest. So let's just copy and paste what we have here. Instead of smallest, let's call this the largest. And replace these variable names. But now this is a little bit backwards because if we just copied it up from here, we're still finding the smallest, but now we want to see if the weight is greater than. So really it's going to be, let's take this weight, if the largest is less than this weight. So if the largest is less than this weight, then this weight is now the new largest, right? And then we return the largest. That's all there is to that one. Find average, a little bit different, and I'll show you why. So let's assume it was kind of the same. We'll have weight equals, here's what I saw a lot of people do, and I'll show you why it's wrong. Or make a loop to go through all of the weights, right? So weight dot add to, and this weight, and the I one. Is that right? There we go. All right. So, and then that you say sum of them, and then of course we need to divide it by the number of them to get the average, right? So we can take this weight, divide. Let's see. Use our method divide, divided by the count. Now we can return weight, right? Something's not right. For starters, when we have this weight is equal to the first weight, right? If we start our loop at 0, the first time in here, we're taking like the first weight and adding it to the first weight. And that doesn't make sense. We've already counted this weight, right? So we may think, well, we can put a 1 here. That way we'll take weight 0. And in the first here, we're going weight 0 plus weight 1. It loops again, weight 2, so on and so forth. The problem is, in our add to method, if we look at our add to method, we are changing the value of the pounds and the ounces inside that class, right? We're updating the pounds and the ounces. And so, since this weight, it is weights 0, anytime we do an add to, it's modifying the value, those pounds and ounces in weights 0. So while this will give you the right answer the first time through, it is actually modifying the internal value of those pounds and ounces inside weights 0, and you should not be modifying that. So what we can do instead is we can make a new weight value, start it off with 0 pounds and 0 ounces, and now we want to add all of the weights to this empty blank one. And then we'll end up dividing it by the count and returning it. And so that's it for find average. All right, so we're done with that one. We're done with that one. We're done with that one. So now we're going to have the main. And right now I got about 14 minutes until the Zoom clock is going to kick me off. Like I said, if we run out of time, then I will send an email with a new link. Like as soon as it cuts off, I'll send an email with a new link in case it cuts off, and then we'll pick back up. I think I can squeeze it out in 14 minutes. All right, so basically what we need to do is we need to read in the weights from a file, and no more than 25, and then call the find minimum, find maximum, and find average on those weights. All right, so first we need a weights array. Weights equals new weights, it's weight. And the most we can have is 25, right? All right, so there's an array of 25. We need to keep track of how many we have. Count equals 0. We need to open a file. And the instruction says to use JFileChooser. It's real easy. JFileChooser. JFileChooser equals a new JFileChooser. You can put parameters in there, or you can leave it blank. You can look up the documentation for what the parameters are. It's fine, it's up to you. We're just going to leave it blank because we don't need the parameters that bad. We'll have a JFileChooser.show open dialog. And the parameter for it says it's the parent, right? And that's really useful if you have like a hierarchy of GUIs and stuff like that. We don't have any kind of hierarchies of GUIs. There is no parent to this, so we can just put null, meaning there is no parent. All right. So what this will do, it'll actually open up the dialog, and we'll just run it and we'll see what happens. So click my little play button here to build it. Waiting for it to compile. And it pops up on my other screen, but there it is. So it just pops up a GUI, and then you got to go find your weights file. And I already have a weights file made. There we go, weights.txt. And that would have opened it, right? But right now, the program ends because we don't have anything else in our code to handle any more of it. All right. So how do you know if they selected a file or not? So if you look at the documentation for the show open dialog, it tells you about return values. We have this one right here. Approve option means they selected a file, and there's other things if they didn't select a file, is the return value. So we'll see if the return value of this is equal to the JFileChooser approve option. So this means if they selected a file, we're going to do this code. If they didn't, then we won't. So let's say they selected a file. Now we need to be able to read from that file. Okay, so we can do it with a buffered reader, new buffered reader, and it can take a new file reader, and then we have to tell it what file to read, and we can do that with the Java file chooser.selected file. And that will open up whatever file they selected in the Java file chooser. Now it does have the red squiggly because we need to put a try and catch around this because it can fail. Put around the try and catch exception E. If there's an exception, we'll just print it out so we can see what went wrong. All right, so this buffer reader will open our file. Now we need to read from the file line by line. All right, it says I got 10 minutes left. All right, so let's read from the file line by line. Starting out, line will be 0. We want to loop reading the file line by line. So while line equals buffered reader, read line, and as long as that does not equal null. What that's doing is each time through this loop, it'll read in a line, put it in the line variable. If that is null, it means it's the end of the file, and we will stop doing our loop. Okay? So now we have line. If you look at my weights, how I did it, I had like pound, comma, ounce, pound, comma, ounce, pound, comma, ounce, pound, comma, ounce. So what we need to do, we need to find a way to break this apart into separate pieces. But the first time in this loop, we read one line at a time. So the first time in the loop, the line will be equal to this whole thing, 1, 1.1, right? And so we need a way to break that apart into the 1 and the 1.1 into pounds and ounces. So we can break that up into an array of parts, and it's the string dot split, and tell it what character you want to split on. For me, I'm using a comma to differentiate between the pounds and the ounces. I could have a semicolon here if I wanted, but then I would just use a semicolon here, right? I'm using a comma, makes sense to me. All right. So now parts 0 is going to be this first number, and parts 1 is going to be the second number. Okay. So let's make a weight out of it. Weight. W equals new weight. We give it the pound. Get ahead of myself. Let's get the pound convert to an integer, because parts 0 and parts 1, they're still integers. I mean, they're still strings. So we need to make integers and doubles out of them. So the pounds will equal integer dot parse int parts 0. And the pounds is a double, or excuse me, the ounces is double dot parse double parts 1. All right. So now we can make a new weight with pounds and ounces. And now we need to add it to our array as well. So we have our weights array at the index of count will equal this weight. And then we need to increment our count. So this will read in the entire file line by line, split it apart into pounds and ounces, convert it to an integer and double, make a new weight out of it, and then add it to our weights array. One thing we have to look for in here, though, is we say it cannot be greater, we can't have more than 25. So if we have read a line in, if the count is already equal to 25, then we need a bell. System.out.print, whatever you want to put, too many numbers or too many weights, and then exit out the program. Right? Because if we came through here and we read 25 things, that means count is 25. When we come back up here, if we read in another line, but we've already read in 25, we need a bell, it's too many. Okay. So that's that. And then really the last thing we have to do is we want to call, we want to do the find min, find max, and find average. So after we've read all the stuff in, which is following along this, let's do the find the min is going to be find minimum on our weights array, and we have that many of them. Weight max equals find max on our weights array, and we have that many of them. And then have our average, find average on our weights, and we have that many of them. Let's print it out real fast. System.out.print. We have, what is it? The min equals plus the min.toString. That's why I wrote that toString method. So that's the min, max, and average. Max, AVG. and change it appropriately, min, max, ABG, and we're done. And so if you look down here in this part of the screen, it'll show us the output from running it. If you look at our weights, I just made them simple numbers so we can kind of gauge if the output is correct or not. So let's run this. It's compiling, pops up my J file chooser. Let's choose our weights file, weights.txt, and here we go. There's our answer. The min is 1 pound, 1.1 ounces. Is that right? Yep. The max is 5 pounds, 5.5 ounces. Looks like the max. And then the average looks like it's about right as well. The reason why you see that they're not exactly 3.3, there's some floating point funny stuff with Java. I can link to it if you want to know all about it later. But that's essentially 3.3. And that is the entire project in about 30 minutes of programming. Easy peasy. From scratch. So, I mean, that will about wrap it up. Like I said, it's 12. I have about 4 minutes until the Zoom meeting will end automatically. What I will do is we'll stop this here in a minute. I will email out a link for another Zoom meeting that you will be able to join like immediately now. If you wish to ask me more specific questions or anything like that. Other than that, I will get this video posted. That way you can go back and see the first part of it where I programmed up the weight class. I'll probably throw it up on YouTube or something like that and then link to it in an email so you can go watch the whole thing. All right. All right, have a good day. I'm going to end this now, and I'll email out a link for a second meeting. All right, have a good day.